Alright, so in this video, I'm going to cover 3.2b, Day 1, Evaluating Functions Algebraically. We're going to answer the essential question, how do I evaluate functions algebraically? So remember, with your function notation, equations that represent functions are often written in function notation. Function notation is a way to name a function that is defined by an equation. We replace y with f of x. So for example, when it says y equals 4x minus 1, in function notation, we would write f of x equals 4x minus 1. F of x means f in terms of the variable x. What it reads as is f of x. This is not the multiplication of f times x. F of x is the output and x is the input. F is the name of the function, not a variable. So remember, we covered this in the last lesson. F of x equals y. X, y are your coordinates, and then your function coordinates are x and f of x. So let's write the following examples in an ordered pair. So f of negative 10 equals 2. So remember, what's inside those parentheses equals your x, and what's after the equal sign equals your y. So if we were to write it in an ordered pair, it'd be negative 10, 2. G of 3 equals 1. Now, G is just the name of the function. It doesn't always have to be f. So remember, inside your parentheses is your x value, and after the equal sign is your y. H of 0, again, name of the function. So we have 0, 1. So use the table below to evaluate the functions. So f of 3, meaning when the function value of x is 3, what is my y? So I'm going to go here to the table, find 3, and use the y value. When the function value for x is negative 2, what is my y? Evaluating functions algebraically. So here are little machines. Think of the function like a machine that takes an x value and produces a y value. So in this particular function, we're going to use f of x equals 3x plus 4. So f of x, so what we put inside the parentheses is going to be our input. Then we're going to run it through our function right here and figure out what we spit out. So let's write our function as our little machine. So we're going to have 3x plus 4. Okay? 3x plus 4. But instead, we're going to replace that x with whatever we put inside those parentheses. So in this case, we're going to do f of negative 2. So our input's going to be negative 2. So I'm going to put it right here where the x was. And in the second case, it's going to be negative 1. So I'm going to put it right in there where the x was instead. All right, so do the math. 3 times negative 2, negative 6, plus 4, spits out a negative 2. So f of negative 2 equals negative 2. Okay. Let's do the negative 1. Whoops. I'm so sorry. I did not mean to write that there. I just noticed it. Of course, my pen dies. I just noticed that I wrote that there. I'm sorry. There we go. So 3 times negative 1, negative 3, plus 4, spits out a 1. So f of negative 1 equals 1. Okay, pretty cool. So we inputted a -2, we outputted a -2. We inputted a -1, the output was 1. So let's try a few more. So f of x equals 4x minus 1. So now our problem is to find f of -7. So wherever we see the x, we're going to put a -7 instead and see what f of -7 equals. What is our output? Well, we're going to have -28 minus 1. So f of -7 equals -29. All right. So right now we have f of x equals -x squared plus 6x minus 4. Well, let's find the value for f of 5. So we're going to have -5 squared plus 6 times 5 minus 4. -25 plus 30 minus 4. So we're going to have 25 plus 30, 45. Yeah, so f of 5 equals 1. Brain's a little rusty this morning. All right, so f of 2 equals -3x plus -3 times 2 plus 1. So f of 2 equals -6 plus 1. -5. And this is how you'd write your answer. You would put your f, your function name, then you'd put whatever x value produces your output. All right, now you try. Please come and see me if you have any issues.